Good evening, everyone.
How's it doing?
I'm not sure if this is live. So, welcome, everyone. Maybe we can wait just for a few more minutes or minutes. Okay, we're live on YouTube. Maybe let's honor African time and minutes. Maybe we can do that. Just a minute. How's it, Masai? Good to see you, man. We'll just wait for a minute or two for more people to join us. If you're already in, let's see. See you, Yolanda. See you, Innocent. Hello, world, indeed. There we go. We here. We're doing this. We here. Thank you, everyone, for taking the time. We really appreciate you joining us for today's session. Just drop us a flag of where you're from. Tell us where you're from, where you're joining us from. I know some of us are joining us in dear situations of load shedding. But thank you for joining us. Thank you so much for joining us. My name is Tuba. We'll just get the show started. My name is Tuba Mamba. I'm a software engineer at Rocket Shop, where we're building stuff in the NFT, electronic dance music. Thank you for joining us. Thank you to GitHub for awarding us this opportunity to do this, to build a community in South Africa. I'm personally excited about the prospect of what we've embarked on, the journey that we're embarking on, building a community in South Africa. And it's exciting, honestly. It's exciting to be doing this with all of you guys. This is not a one-man show. This is about the community at the end of the day. Thank you guys for joining us. Basically, today, what we want to focus on is code and community. I will tell you guys right now, the speakers are amazing. I think amazing doesn't even begin to describe all of these guys. Everyone here is talented and experienced and passionate about what they're doing. And I'm sure that today's session is really going to change. Is really going to change how we deliver software, how we approach our careers individually. It's really, really exciting. We do have one speaker joining us, Gordon. He's running a bit late. I know it's a virtual thing, but technical problems. He's going to be joining us. So maybe just to kick it off, why we're doing this is because much as there's a high demand for people with tech skills, there's also a demand for growth as well, which is why we're here today, which is why we're establishing the GitHub South Africa community. With it will come opportunities for growth, opportunities for networking within the space, from Joburg to Cape Town to Limpopo to even rural South Africa. And above and beyond that, we are excited to also be impacting to the neighboring countries. So countries like Eswatini, countries like Botswana, like Lesotho, and so on. We really believe in the community. We really believe in the fact that for us to better build a much bigger and better community, it starts with such events. It starts with us bringing the community together. Without any further ado, I will introduce VT. I'm sure people know him as Churches on Thursday. He's a software engineer. He kind of cares a little too much about FIFA, and he definitely loves sharing what he knows in the space. I'm excited to have him on here. I'll tell you guys right now, the stuff that is going to be dropping here is amazing. Please do share on Twitter, hashtag GitHub community, hashtag ZATech. Bring a friend, tag a friend, grab a beer. Let's do this. I'll leave you to it, Viti. Thank you so much.
Cool. Thank you. Very tough introduction to actually live up to. I don't know about dropping like the most amazing things, but I'll try. I'll try my best. Thanks for thanks for having me here. It was tough, deciding what to talk about, but I've seen a lot of teams struggle with delivery, so I thought it might be like a nice thing to to talk about. So tonight I'll be talking about delivering faster with trunk-based development and feature flags. So a little about myself. I'm VT. My current role is Chief Technology Officer at Basalt Technologies. That usually means I'm involved in building, running, and helping our teams within the space. So I'm often faced with making sure that teams are delivering. If you have any questions, you can reach out to me on Twitter. I'm fairly active. As Tuba said, church is on Thursday. We host a space under the hashtag ZA Tech Radio every Thursday, which is another great place to come and ask questions. So what's the problem that we are talking about tonight? Well, delivery is hard. Writing code, getting it into production, and making sure that it meets business needs is extremely difficult. So, as you all know, in almost every team you work in, you've got different streams and the same code base. So you're working on different features, bug fixes, hot fixes, as well as maintaining code at different levels, right? So the solution to the problem of having multiple streams has always been branches, right? And I'm going to assume that all of us are here using Git. So, you're familiar with what branches are and don't have to explain it. But whatever company you work on, the likelihood of your space looking like this is very high. So in most cases, you've got a develop branch, which is where you're pushing all your code. And then you've got a master branch, which might, recently renamed to main on GitHub, which might be pointing to the code that you have in production. And in between, you might have things like your releases, tagging those, as well as like hot fixes, and like this very convoluted way of working. It is organized, but there are some problems that exist with it. One of them is merge hell, right? We've all been in the team where I started a feature about 2 months ago, and now I want to get back into develop, and it's just not possible. That's happening because, the rest of the code that is on the current trunk on develop has kind of like diverged from the code that you have on your local machine. This leads to problems like semantic conflicts, regressions, undeployable code, and so on and so on. We've all run into that case where we just don't know what's happening at all. A little disclaimer before I continue: I'm not saying things like Git flow are bad. I don't think there is such a thing as good and bad in software development. I think software dev is a game of trade-offs. But this method can slow teams down because of the issues stated above. So how do you deploy much faster, right? Which brings me to the conversation of the day for me, which is trunk-based development. What is it? Well, what do I understand it to be? I think if you talk to people or you look it up, some people might tell you that trunk-based development means everyone is working on trunk, right? So no feature branches or anything like that. Everyone is just kind of just pushing the code to the main branch. And I know teams that have tried that, and obviously that comes with its own issues as well. But I don't quite think that's what trunk-based development is. I think trunk-based development is guided by a few principles, right? So as I said, the number one being that you have one trunk branch where devs merge the changes. This branch is, it can be called anything. It can be called develop, it can be called main, it can be called master, it can be called release. You can really call it whatever you want, but the main idea is that there only exists one, which is like the golden source of truth. The second principle is that devs should merge small changes as often as they can. As I said before, contrasting it with Git flow and other approaches where you might have a feature branch that lives for maybe as long as 3 months or something like that. With trunk-based dev, like the principle is like merge as often as possible, multiple times a day, but aim for at least once a day, right? Which obviously I can, almost sense, people watching saying, okay, cool, merging every day. What if I'm not done? Cool. We'll get to that later. The third principle is that merges must be reviewed, tested, and must not destroy the trunk, right? And there's multiple ways of doing this. One of them is like pull request. So you have your colleagues looking at the code and checking it against your team contract. Are things done properly, and just kind of looking for any code smells or things like that. But another good way of that of doing that is like having unit test, as well as integration tests to just make sure that the expected code paths are still working. And some teams might opt for something like TDD, which does this very well, to say, every piece of code that we have is, or at least as much of our code is tested automatically. And when you submit your pull request, you can automatically check that nothing existing has been broken and the new code has been tested. The fourth principle is that all code that is in trunk must be ready for release at all time, as far as reasonable. The ideal would be that you maintain a green pipeline throughout. Obviously, this is a real world, so maybe it's not always something that you can achieve, but it's something that you should definitely be aiming for. And then, the fifth one is that feature branches must be short-lived. So as I said, I don't believe that trunk-based development means working directly on one branch without branching, but you do employ some branching. You just make sure that those branches are short-lived. And the last one is keeping your commit messages as concise as possible and also meaningful, right? I've seen people type, I hope this works, that type of thing. But in trunk-based development, having your feature branches being descriptive as well as your commit being descriptive just helps with a meaningful log of work that has been done. Cool. So that means that we move from this kind of picture to something a bit more simplified. So as you can see down the middle, you have your main branch, which is your trunk. A developer can check out from trunk, work on the feature, and merge back on. And then you can branch out of that, create a release branch, release to production, and merge back in. The following that flow, but making sure that the trunk is always functional. But that's hard to do, right? Because in the practice of making sure that you have branches was not by accident. As you said, it solves the problem of people working on multiple streams, but it introduces another problem, mainly being merge hell. When you get rid of those feature flags, suddenly your branching by source control goes out of the window, but branching is still necessary. So you can introduce something like branches by abstraction, and this can be done with feature flags. So I'm going to show a bit of code around that. There's an example here on the screen currently in TypeScript. I hope everyone here has at least worked with React and TypeScript, and this makes sense for them. But trunk-based development uses feature flags as a mechanism to manage like new feature releases. So a feature is simply like a Boolean condition that modifies the behavior of a component, a module, or a function in your application, right? So like following a feature flag pattern traits the simplicity of like having an isolated branch workflow, such as Git flow, as I've mentioned, in favor of something a bit more flexible in feature rollout, continuous delivery, and application personalization, right? So a simple way to begin using feature flags is to maintain like a single file containing your feature flags. So as you can see there, the feature flags.ts, where I have hello world new feature initially set to false. The feature flags can also be managed through like external tools, like Launch Darkly or Optimizer. Here, the new feature is returned based on the flag. So hello world new feature is like the flag. If the flag is true, then the feature create new hello world is returned. Otherwise, the old feature create old hello world is returned. Right. This TypeScript module like feature flags or TS can be like extended to fetch the features from external or internal services. But there's also an approach of thinking about like existing feature development with feature flags. So it's quite easy or straightforward when you're working with like introducing like a new feature as you can see above. But you might have a case where you already have like existing features that you want to slightly modify. And it's slightly more complex, but offers more flexibility for continuous delivery and personalization, as I said. The first type is like applying a small incremental change. So if the proposed feature is a small incremental change, we can modify like an existing code path to like augment behavior. So take the following example. Where we have an existing calculation. So our function returns quantity multiplied by value, and we want our new calculation to include text. While we're still working on that feature, we simply say if that feature flag is enabled, then return quantity times value times text. Otherwise, return like the old calculation, right? But this is quite like straightforward. You could also have like a large modification. So if the proposed feature is large, for example, we want to display like a completely new text calculator component, we would need to find a new code path and entry point for that specific component. As you can see here, so instead of something as small as that text calculation, we return a whole other component. And like new feature flags are very helpful. I've met a lot of people who've said feature flags make everything very complicated, but you can find a way to simplify it by trying to make sure that the change is localized to the entry point of your code base, right? So new feature development with feature flags is simpler than existing features, but it's not impossible. But since there are no existing code paths for your code to execute, the code path will be disabled by default while this feature is like a work in progress. And a few things to keep in mind are that new feature development process with flags should look like what you have on the screen. So you create a new feature flag for your new feature. You begin working on that code. You ensure that the flag is false before merging into master or main. And then make sure that you merge your code frequently. When the feature is ready for release, then you remove the flag. And in conclusion, I think trunk-based development and feature flags together can be used for continuous delivery, delivering the features faster to market. Planning them carefully, however, will allow you to quickly deliver the new business features to the system. The feature flags can also be managed through external tools like Optimizer and Launch Darkly, and tools that provide SDK to manage the features or that are external to their application. I think my time is up, and I hope that was useful to a lot of you. As I said, happy for you to reach out after this. I think there will be time for questions, but I hope to see more teams and more people adopt feature flags and trunk-based development to help the businesses deliver faster. Thank you.
Thank you, VT. That was brilliant. I see a lot of people are still joining in. That was brilliant. Thank you so much, VT, for sharing that. You guys can connect with VT on Twitter at VT_codes. I do see a question here. There's a question coming in from Steve. I believe Steve is in Malawi or Kenya. His question is, what should a standard commit message look like? Can you maybe
Cool.
just zero in on that, VT?
Yeah, look, I think there are multiple practices, but the format that I go with is, first of all, just like breaking down my commit message into two, right? So the top one being a very short, brief description, right? So let's say there's a bug there's a bug causing users to log out when they refresh, right? I'd precede like that message, that description with my Jira ticket number or my GitHub issue, right? So it could be issue number 11, so hashtag 11, and say fix bug causing users to log out when they refresh or something like that. Keep it short. I try to keep it just under like 100 characters or even less, just to make sure that it's easy to read in the when you like quickly glance at the at the history. But I try to make sure as well that like under the message, I make sure that I have a description, especially for like very tricky bugs, where it might be like a unique case where you might need to apply a hack. So same format, very deep, brief description, and then underneath you go into the detail of what the problem was, this the approach that you've taken, as well as like why you've taken that approach, and maybe any caveats that might exist. It just helps when someone else is looking at a piece of code and says this is very crappy code, and then when they look at the reasoning, they're in the same mind space you're in when you commit it.
Yeah, cool. That's great advice. I see Human Solarian commenting there. Less is more. I totally agree with that. I think that less is more, and just making sure that anybody that's going to be touching that code base as well shouldn't be confused as to what's going on in here. So I like your approach.
But not so little as so that like it's vague and the person can't get context from it. So like WTF as a commit message doesn't help anyone. But try to keep it brief, like implemented a new login version 2. It's quite easy. Yeah.
Cool. That makes sense. Thanks a lot, VT. Thanks, man. Personally, I've learned a lot. Thank you so much for joining us. Let's meet again. Again, you guys can follow VT on Twitter at VT_codes. Churches on Thursday. Hashtag ZA Tech. We're doing this. We do have one speaker coming up, Derek Crossan. I personally met Derek a couple of years ago. He's the gentleman responsible for introducing me to Ruby and Rails. Thank you, Derek. He's got a background in system administration, enjoys doing maintenance work, working with tools that automate tasks and make systems more stable. He's currently working for DocFox. He's going to be taking us through delivering software delivery with Spinnaker. I will hand it over to you, Derek.
Awesome. Thanks, man. Let me just share my screen. Sorry, present. Can you all see it? Cool. I think it's on screen now. Awesome. So yeah, today I'm going to talk about software delivery with a tool called Spinnaker. Got some good news and some bad news. My talk was mainly focused around a really awesome demo I was going to do, but I kept hitting the resource limits and I was trying to create the infrastructure. So we'll probably like record a video and send it out to you soon. But I'm going to try and make sense of what's on the slides and hopefully you'll understand it. So cool. So this is what I'm going to chat about. Just tell you a little bit about myself in like a minute or two. Then give you an intro into Spinnaker and talk about how it came about, what problems it solves, its concepts, and then talk a little bit about monitoring resilience. And that would have been the place where I did the demo, but that's not going to happen today. So this is a really bad photo of me. My name is Derek. I'm a software engineer at a company called DocFox. We do onboarding of businesses and clients, and basically we build compliance software, and we like scan terrorist database and political party databases and that kind of stuff, and make sure that people aren't money laundering. I used to do system administration and technical work years ago, and what I want to do in the future is more of DevOps work and less writing features. So that's me. Cool. So Spinnaker, what is Spinnaker? So Spinnaker is this tool that helps you manage the delivery of your software, and it was created by Netflix, and now it's used and maintained by loads of different companies. It's written in Java, and what it does is allow you to continuously deliver software, and also like run your software in multi-cloud environments. So for example, you could have half of your infrastructure on Google, the other half on Amazon, Azure, etc. So one of the problems that Spinnaker solves is you have like complete observability into your software and what's going on at all times, and I'll talk about that more a bit later. Cool. So some of the main things to grasp in Spinnaker is everything kind of revolves around these things called applications, clusters, server groups, and pipelines. Sorry, ignore the descriptions here. I just realized I forgot to put in the proper ones, but they're on the next slide. So applications are clusters which in turn are collections of server groups, and applications can also include firewalls and load balancers. So an application is basically, in Spinnaker, an application is a service which you will deploy. So for example, if you have a login service, a single sign-on service, and a service to upload documents, for example, those will be seen as two separate applications along with all their configurations and the infrastructure that will run on that those services will run on. That's just basically the definition of an application in Spinnaker. And then we also have these things called clusters and server groups. So server groups are the deployable artifacts, such as like a Docker container or an AWS AMI, and the configuration settings like the auto scaling settings, the number of instances, any policies, security policies, etc. And these, you can have multiple of these server groups within a cluster, and they can also be connected to a firewall or load balancer. So when deployed, a server group is just basically a collection of instances running your software. And this is what a cluster will look like in Spinnaker. This was supposed to be like part of my demo, but I just had to find some screenshots since that's not happening. So you have your different your environments with all these green things, and these red things are actually instances. So these would be either like containers or machine images, etc. And in this case, you'll see that they are behind the load balancer. So that's just basically what the UI looks like. And then another important thing, a very important thing, is pipelines and stages. So almost everything in Spinnaker in terms of delivering the software is reliant on a pipeline. So a pipeline is basically just a sequence of actions and events known as stages. And within those stages, when something happens and you like output certain values, you can pass those params from one stage to another. So a pipeline can be triggered in multiple ways. So in some cases, you'd want to trigger them automatically, like when a job completes in GitHub Actions or Jenkins or whatever tool you're running. Same for if a container is created in a registry, you might have an automatic pipeline trigger. And there are also cases where you would manually trigger pipelines. So in cases where like your pipeline goes through a process of testing and deployment to a staging environment, you'd usually have like your QA engineer that will do whatever test they need to do, make sure everything runs, and then it will either be the QA person or a product person who would actually do like a manual step and approve that. And once they do that, it will automatically deploy to production. Cool, and this is just an example of a pipeline in this case. There's a bunch of things going on here, and you'll see that there's these 2 periods where the pipeline will wait and then deploy. And you also have these steps where you can like manually override certain things. So in this case, if you're happy with whatever is going on here, you can just manually override, and you don't have to wait for the 30 minutes or 2 hours in this case. And within Spinnaker, this is what a pipeline would look like. So in this case, what this person was doing is they had their test running in Jenkins, and they have probably a containerized application. So it goes through this bakery process where it's basically just an image being created or an artifact being created from a Helm chart or something. And then once that's done, it will deploy. And yeah, in these steps, you'll see that there's these things here, and it's got a status. So what will usually happen is your application will be behind the load balancer. Let's say, for example, you have like 3 instances running, and as soon as this deploy happens, it will put this new image behind the load balancer and take one of them off. So that's why you deploy with no downtime, because the request that's on the instance that's being taken off the load balancer is still continuing, but the new requests will go into the other containers, which is just something that's quite smart to do. And also, the containers can be destroyed immediately, or you can keep them for whatever duration you want to keep them for afterwards. So that makes it very, very easy to like roll back within like minutes if something goes wrong, because all that the software is doing, the build system is transferring instances to and from the load balancer. So you can easily roll back or roll forward when things go wrong. This is also quite helpful in cases where like you get something going wrong in production, you test it on staging, it's all good. And like you can only test again in the night on production when people are offline. So in that case, you run the roll forward again. And should you like delete the old image, you can still roll back. It will just take a little bit longer because it needs to go through the process of creating the artifact again. So yeah, that's basically some of the stuff you can do in a pipeline. And then Spinnaker also supports multiple deployment strategies. This is just a few of them. Red, black, which is actually blue, green. For some reason, Spinnaker calls it red, black, rolling red, black, and canary analysis. Canary analysis is quite cool, where you can like release part of the feature to some users, and some users get something different, kind of like A/B testing. So yeah, I've got some resources at the end of the slides, which actually it will like one of the links will take you to all the different deployment strategies that Spinnaker has, and it will explain what all the differences are and actually show you in diagrams how they differ. Cool. Then another thing that's important with any system is monitoring and alerting. So Spinnaker supports Datadog, Prometheus, and Stackdriver out of the box. You just need to put in your credentials in the right places, and they'll work. And you can send that data to a different tool like Grafana or whatever you use for your graphing and dashboard creation, and will just make things easier to look at. And within a Spinnaker pipeline, at any given point, you can also send out alerts for specific events that happen. So, for example, when a pipeline is triggered, you can send a message to Slack or a text or email or whatever you want to send. Same for if it fails, and just when an image is baked or whatever you find necessary to send an alert for. So yeah, that's just like the default monitoring that it has. And something like that's often not practiced enough, I think, is resilience. So your software needs to like scale and be able to like fail over, and you need to have like proper insights. I also didn't update that description, sorry. And practice chaos engineering. So in terms of scaling, what many larger companies do is they use microservices. So they keep their services as small as possible and horizontally scale them. And often this is done using a tool like Kubernetes. And with that, what you can do is you can allow your, there's these like containers that are called pods. So what you can do is set a minimum and maximum value, and it'll always try and keep it within that range. So when you have automatic scaling turned on, and even when you don't, it will do what's called self-healing. And when one instance of your software goes down, another one comes back up immediately. So that just gives you high availability and prevents many issues if it's done right. And then in terms of failover, there's a bunch of different ways to do this. With the bigger companies, what they usually do is they run multi-cloud setup. So they'll have like a Kubernetes cluster on AWS, another one on Google Cloud or Azure, or maybe all three. And then when a request, what the first will do is when a request fails in one region, it will automatically fail over to the next region. And then if, like, for example, AWS is down, it will end up getting rerouted to Google Cloud or somewhere. And there's a bunch of different ways you can do that. In terms of insights, that's is also like part of like the previous slide. If you know what's going on at all times, you can prevent things from happening. And often we get like certain insights and alerts that maybe not very useful, but we don't get enough of the stuff that we don't spend enough time like getting the insights that we could get to like make things more stable. So if you like go and Google like how Uber detects their incidents and stuff, they've got some really good articles. I forgot what they call their tool, but they've got some really cool articles where they explain how they use like production-like environments, and even their stub data for their test users are like almost like production. And they have like the single page where they can view whenever something's going wrong anywhere in the world. And if you like catch it at the right time, you can prevent like the whole world having issues compared to just one city. So I'll try and find an article and send it to, like, post it in the chat or something. Then in terms of chaos engineering, I think Netflix are probably like the best at this, and they have a tool called Chaos Monkey that's actually built for Spinnaker. So like in a lot of the talks I've watched from them, one of the things I've often noticed is they talk about experimenting versus testing. So often when we're doing like QA or doing like any kind of testing to see when things are going to go wrong, we often testing for specific cases, whereas we should be like testing for things that probably aren't going to happen, or just doing random stuff to see what happens. And that's how you end up like preventing a lot of race conditions and just making your software more stable. So yeah, that's just like a little bit about resilience. And then this is like an example multi-cloud environment. So in this case, you got Google Cloud and another vendor. You can assume this is maybe AWS, and you've got some Kubernetes clusters, some ingresses, and some Kubernetes pods. So what would happen would be this is all behind a Cloudflare load balancer. So the user would visit this address, and while this request is being made, if the pool goes down or if there's something wrong on the one side at this point, it would reroute the request before the TTL expires. So what happens is everything just seems normal. The user doesn't even know there was a problem, and they have a really good experience. And in most cases, your team won't even have a problem unless if your team won't even notice unless you're like closely monitoring the log, or unless it's like a major outage. And that's probably like the way it should be, because small outages should be handled this way. And if it's something bigger, then you need to look into it. So that's just like a simple example of a multi-cloud setup and what it could look like. And then like the result of all of this, delivering your software in this manner and chaos testing, especially with production-like data or even in production, it just makes things more stable, and it helps prevent like lengthy outages and loss of revenue. So the happier that your customers are, the more money you're going to make in the business, and everyone's just going to be more happy, provided you got a great culture. And then I've just put in some resources on the slide. So if you're interested in Spinnaker, Home Depot, believe it or not, their engineering team wrote something called SpinGo, which is probably the easiest way to set up Spinnaker. It's enterprise grade and production ready with all the security and everything. But yeah, if you do this, I recommend contacting whichever cloud provider you're using, getting in touch with their sales people, and getting the access to the resources you need, so you don't have the problem I had. And then there's a bunch of other resources like a YouTube series on Spinnaker and why we need chaos engineering and that kind of stuff. And check out this as well. It's called Opta. It's like Terraform, but it's very high level constructs, and they even have something called like a playground or something, I think they call it, where you can like generate your infrastructure code without even writing code. You just click buttons and say like you want the VPC in AWS and this and that, and it will generate the YAML file for you, which is pretty cool, and it uses Terraform under the hood. So yeah, that's just some of the resources that I put together if anyone's interested. And I will record a demo soon. Sorry it wasn't available tonight. I hope some of this made sense, at least without the demo. And then, yeah, thanks. So if you got any questions, this is my details. You can contact me just to chat or connect with me on LinkedIn or GitHub or somewhere. Yeah, awesome.
Cool. Thanks, Derek. That was amazing. I see there's a question in there from Steve. Does this enable auto scaling? Before you respond, all I heard from your talk was no more Friday deployment headaches.
Yeah.
I think everyone that's on here will agree to, there's usually headaches on Fridays because, poor infrastructure and whatnot. So I think I love the Spinnaker tool. It will really just, enable better engineering. But yeah, we've got a question from Steve. Does this enable auto scaling?
Yeah, I would have loved to have done the demo so I could have actually showed you how to do the config and stuff. So auto scaling is more about the infrastructure you're using like under the hood. So with auto scaling, you'd probably want to use something like Kubernetes to deploy your services if you've got a bunch of services, and make your Kubernetes cluster auto scale. So make sure that the nodes auto scale or the pods whenever you need to, based on whatever your loads are. Okay. And you could probably do it with like other images as well. But yeah, your Spinnaker is just more like the management and delivery tool that gives you like a high level of observability. And also when you log into the dashboard, it also shows you like your uptime and a whole lot of other stuff that we didn't see in here.
Okay. All right, cool. I hope that answers your question, Steve. And just a question from me. There will not be any surprise bills coming from AWS if I use AWS with this. Some 10,000 Rand, 10,000 Rand bills coming in.
Well, if you're auto scaling, that could happen. But it's all based on your load. So yeah, it's with any cloud provider, I think it's easy to make a mistake. But like I said, like before, this is just a management tool. So you're still writing the code to say this is how many resources you want, and this is when you want them. So usually if your code is really good and your infrastructure is solid, then when you're getting more builds, it's a good thing because it means you're getting lots of users, and hopefully they're all paid users.
Yeah, hopefully. Thanks a lot, Derek, for taking the time. We will make Derek's slides available as well, and he did mention that he's going to be recording a video. I'll post it out on Twitter as well, just so that you see the demo as well. I do see a question from Henry. Thank you, Henry, for that. We're going to bring VT back on. But for now, we do have our last speaker for today. We had a speaker scheduled, but unfortunately, she had to undergo some sort of procedures with the doctors. So we just hope that everything went well and she is getting better. But we do have Gordon beaming. Gordon is a father. He's a software engineer, I believe, as well. He's a DevOps specialist at what's the name of the place?
Derivco.
Derivco, yes, Derivco.
Yeah.
And he's also a Microsoft MVP. He's going to be dropping some amazing stuff on. He's going to be talking on why GitHub. Why GitHub. So please help me in joining Gordon to the stage.
Awesome, great stuff. Thanks. Yes, I thought something a bit lighter to finish us off. We sort of dived in some deep topics, which if you've had to have those conversations at work, you know, they get a very sort of, I think energized might be the right word to describe that. It's sort of a tabs versus spaces conversation when you start talking about branching strategies. And I think VT personally called me out when he says your commit messages and the hope this works, because at some point when things just aren't working, I tend to use emojis to explain my current emotional state as my commit message, because I really have nothing else to say. But now that that's done, let's dive in and see the sort of why GitHub. This largely from my perspective of how sort of my career and how things started off, and sort of how we are now, and why you should potentially start using GitHub if you're not. So a little bit about me. You heard a little explanation already. So yeah, father, husband, currently a DevOps specialist at Derivco. I also am a triathlete and do other ultra endurance sports. And then yeah, some Microsoft MVP for GitHub and Azure DevOps. And just a disclaimer, because we need those these days. Like all my opinions, of course, my own. So come at me with the pitchforks, and not any of the other guys that you might think I represent. Cool. So why GitHub? Where did we get started? So long ago, and sort of discussed a bit by VT, introducing source code. We did very dark things. So some of those things could have looked like the picture you see on the right-hand side there. Those folders aren't Git tags. Those folders are, I think my code's at a good place now. Let me copy the folder, paste the folder, change the name. Or what you do is you copy it and you paste it and you say underscore back. And then when you copy the next one, it becomes underscore back, underscore back. And eventually you have a whole bunch of those folders. And it gets interesting when you want to roll back. You also tend to then have lots of comments in your code, and not the good kind of comments. You have comments of huge code blocks that are there for in case you might need them later, which is all the kinds of things that source control solves for you. And then from a backup perspective, when you say, well, I use the cloud, right? You might turn to saying like Dropbox or OneDrive, and then you have your code sitting in a folder that's synced. And in that way, your code is at least backed up, and you sort of don't have to worry about losing it completely, which again is something that when you're using version control, especially if you're pushing, in the case of Git, to a remote source like GitHub, that's sort of taken care of for you. So next, I'll just run through some of the things that GitHub has and why I like it as a platform. So the starting point, of course, like I just mentioned, is that it has source control. So if nothing else, push your stuff to GitHub. You can have as many branches or as many repositories as you want. So push all your code there. If it's some random project that you kicking the tires on, you're not sure if it's going to be anything, just push it out there. Get into the habit of always using source control. Locally in Visual Studio, even if I do have a repo locally just to some random console app that does, I don't know, some parsing of text files, I'll put that under source control, even if that is just Git on locally. I don't push it to a remote source. It just sits locally, but it's always still under source control. Basically, just build that habit that is part of your life and how you work day to day. The nice thing, though, with GitHub is it's not just a source control platform. So forever ago, as I mentioned, I sort of had these folders and you'd rename the folders, and that wasn't great. Then I moved on to something called Codeplex, which was an interesting beast. It basically did source control for you, but it allowed you to sort of integrate with any, with a lot of different kinds of tools. So you could use SVN into there. You could use TFVC, which is the Team Foundation version control. You could use Mercurial. And the platform itself was great. And it started building, like for me personally, good habits into having your source control somewhere, your source somewhere else that's not on your machine only. But the nice thing when you're using a platform like GitHub is that once you start putting your source out there, it's also got a place for you to start planning your work. So whether that's you just jotting down a bunch of issues, saying, I want to add this feature, I want to add this other feature, I want to add this other feature. Or if you go a bit more complicated and use the projects feature that was recently, I think now in public preview, where you can manage more complex projects. Like it gives you everything you need to manage what you want to do with your work. So don't have a notepad locally somewhere or a bunch of comments in your code that says, well, I need to add a button to this page. I need to go and make this one thing green. Rather come create issues for that. And later on, when you start building a community, your community can come log issues to tell you, hey, they found a bug. And they can give you some information around what they found with that bug so that you can then go and fix that for yourself. As part of that process, and because I mentioned community, there's pull requests. So if your code is public to everybody, anyone can go there, fork your repo, make a change, and submit a PR to you. So if there's some parsing bug that someone's logged an issue for, I can walk up to your repo. I can be like, oh, there's this parsing bug. Go and fork it because I think I know how I can fix it. I fix the bug and I test it on my side and it works. And then I submit a pull request to you. You accept that pull request, and now I've contributed to your project. That bug's fixed and you don't have to fix it. And that's what's great about GitHub is the community. So you can see in this case as well, you'll notice with this PR, it says it's busy running some checks, or some checks haven't completed yet, which is that little section at the bottom there. In this case, it's busy running a workflow that's busy checking that everything's okay with this build. So it's busy doing a CI build just to make sure that the code functionally works. At this point, you generally have tests running, potentially deploying to integration environment, running a bunch of automated tests against that, and just verifying that the quality of the code that's coming in is actually good enough to go into main. And these kinds of things is what facilitates things like trunk-based development, which VT mentioned earlier. Once that's done, you basically click a button that merges that code into your main branch, and you can move ahead. I slightly touched on it, which was the fact that a workflow was running in the background. In GitHub, the platform, the part of the platform for that is called GitHub Actions, and that runs multiple workflows that you can trigger off almost any events inside GitHub. So if someone creates a new issue, you can run a workflow. If someone adds a new comment to an issue, you can run a new workflow. If there's a new pull request, you can run a new workflow. pretty much anything that you want to almost automate on the platform, you can run a workflow for. And then, of course, the obvious thing that of actually building your software and packaging it to deploy it into environments, you can also do that with GitHub Actions. So if we dig into this workflow specifically, you can see there's a whole bunch of jobs. So there's a build job, there's one that downloads backup files, there's one that logs into the GitHub container registry, and then we do a Docker build image, which we also push then to that GitHub container registry. So not a very complicated workflow, but for the specifics of this project, that's all it needed to do. And if we open up one of those jobs, you can see that you have the command line output. So if you were running this locally, that's the kind of thing that you would see. So from debugging, you are able to see that inside the platform. And if you do click on like the line number there, you'll get a direct link to that line if you do need to share that with a friend to say, like, you don't know why maybe something's breaking on a certain line. Once you sort of go past the sort of intermediate stuff of the platform and you start looking at security, which also these things are literally just going and enabling some toggles that says, oh, I want some more security, please. In the case of code scanning, that's using, in this case, an external provider called Snake. But what they're doing is constantly scanning the code to check for security vulnerabilities and then surfacing that in the interface for me to be able to see where I have issues with my code. As part of the platform, you can see there's a little tab there for Dependerbots. So what that will do is check for any dependencies that you have. So they're NuGet dependencies or NPM dependencies that might have vulnerabilities. And in the case of Dependerbots, it actually makes the pull request for you, giving you all the information of what the vulnerability is. Obviously, because it's changed code, you get to see exactly what the dependency is that it's updated. And then if you have your CI builds in place, those will run to validate that nothing's breaking by updating that dependency. And then you can just pull that that updated change into your main branch again without having to do any real work there. I mentioned it earlier, but obviously the big thing about GitHub is the community. So from the Octoverse update, latest update from, I think it was last year, I said that there's 56 million plus total developers on GitHub, and that 72% of the Fortune, that's supposed, was it, I thought it was 500, maybe it's 50, maybe I typoed. Companies are using currently GitHub Enterprise, and that specifically in 2020, there were 60 million plus new repos that were created on the platform. So when Derek was talking about scaling, like just imagine all that workload on GitHub and you never notice it. The experience you get using the platform as if you're running it locally on your own machine and you are the only person. That's how well the platform currently scales. So there's a lot of, obviously, cogs behind the scenes to allow that to happen. But this gives you an idea of the sort of size of the service. So you could be certain that if you join it, you're going to have a great time. And then again, last year specifically, there was 1.9 billion contributions. So that'll be new issues, commits, pull requests, those kinds of things that were made on the platform. Again, talking community, you don't have to always sort of host your own stuff. So yes, hosting your own stuff on the platform is a great way for you to keep a backup of your source, get used to using the technology. Often these days when you go into job interviews, like, well, do you have any experience with CI and CD? What source control do you use? For you to be able to point someone to your public GitHub profile, where they'll be able to see what you've interacted with, what you host yourself there, like what that looks like. That's a huge benefit from a career standpoint for people that are looking to hire you. But then away from having just your own stuff on the platform, as I mentioned, you could go to something like .NET. So if you do work with .NET Core, or now it's just .NET since .NET 5, you can go to that repo and you can look for the issues. So if we go to ASP.NET Core specifically, you can see that there's a whole bunch of issues that get logged there. And if you look specifically for a tag in most repos saying good first issue, you'll find things that the maintainers of that repo, so the guys that work with the repo every single day, have looked at and have deemed a good issue for someone who's new to that code base to look at and to contribute to. So what that'll basically mean is you're going to go fix a bug or add some small little feature to the code base. Once that gets accepted into the pull request, millions of customers, in this case for ASP.NET Core, millions of customers around the world will be using code that you wrote. And it's all because you came to something as simple as an issue in GitHub, saw that it looked like something that you could do, you made a PR, it got accepted, and that exposure and contributing to all those open source projects will help you as a developer be a lot more attractive for being hired, as well as your experience and exposure to things will be great doing things like that. And then I mentioned your profile. So when you on social platforms or like with your CV, have a link to your profile. You can see at the top there, you get to, if you create a repository with your same username, your README file will be shown at the top. So you can put a little bit of information about you. You can then go and pin some repos that you're contributing on as sort of pins for people to like go dig into those and say, like, these are the ones that you're, I guess, most proud of or that you want to highlight as part of your profile. And at the bottom, you have a, wow, my brain just lost the words, but it's your commit graph of which days you've committed code, or it's actually now it's which days you've interacted on the service. So that's issues, commits. So you can see there's specific to contributions now. It's commits, issues, pull requests, everything on the platform. And the darker the green, the more you contributed on that specific day, which is quite nice for you to go and be able to see and use as obviously your personal portfolio. And that's a quick overview of issues. Obviously, I didn't demo anything. 15 minutes is very quick. But yeah, reach out to me on Twitter or LinkedIn. The link to my personal portfolio, where that links out to every other social platform that I'm on, is also mentioned at the top of the page there. I'm always willing to help out wherever I can. Thanks.
Hey, Gordon, can you hear me?
Yeah, I can hear you.
Oh, cool. Thanks, man. Thank you so much for that. That was quite less intense than Derek and but
yeah, just keeping it light.
Yeah, you kept it really light, and I think version control and learning how to do it properly is one of the most fundamental skills in tech, especially as a software engineer. You really don't want to get in the workspace. Sure, you can now use Spinnaker, you can now do everything else, but once you have missed the mark of, you've missed the importance of version control, then you might just have a problem with particularly larger teams. But yeah, I don't see any question. I think mine would have just been to highlight the importance of what you've been talking about, and thanks again for taking the time. Thank you for sharing your knowledge. To everyone, you can reach out to Gordon on Twitter at Gordon Beaming and LinkedIn. We will make these slides for all our speakers available, as well as the recording. I believe will stay up on YouTube. But we will bring VT back up. I know there's a question earlier from Henry.
From Henry, yes.
From Henry. So Henry's question is CDD replacing Gitflow, or is it built on top of Gitflow?
I have to tread carefully here. I don't want people to storm my Twitter and.
Gitflow is highly.
I don't want people to storm my Twitter and tell me that I said Gitflow was cancelled. Look, I don't think it's a matter of something replacing the other. Like I said in the beginning, my disclaimer. I think programming is a game of trade-offs, right? So there's certain considerations where you need to look at what you're doing in order to decide which one works for you. For me, I have 5 of these things that I look at. So team composition, the product type, the authoring process, the deployment, as well as the release frequency. So, for example, if you have if you lack seniority in your team, so you have like a team full of juniors, or you're working with like vendors or third parties, then I would opt for Gitflow, because it kind of like lends itself to a bit more control, where you might want to keep a keen eye on things. If you are, a well-composed and experienced team, or you're, augmenting a team, so you're all working together as opposed to like a third party contributing, then trunk-based development might be something that works. When you look at product type, if you're working with like a complex, mature, or monolithic product, or a brownfield, product, something that already exists is in flow, Gitflow might be, something very good to use there. Where else, if you're working with like microservices, or you're building like proofs of concepts or prototypes or distributed system components, trunk-based development might help. Like imagine like the onerous process for like 100 microservices and wanting to like use Gitflow for each one of them. The authoring process as well. Look, if you have something governed normally, like where you have a team that has like a release train engineer or like a release manager, so like super governed thing, you might want to use Gitflow. But if the authoring is like team driven, then trunk-based development might be the thing for you to use there. If you look at deployment, you might have like various models where you have like a release manager, and they want to deploy on a specific day, and they want to like decide that person might decide what goes in or what doesn't go in. That kind of control might require you to use Gitflow. Whereas if you want to lean more towards like continuous deployment practices, things like feature toggles, self-service automation, so things like GitOps and ChatOps, then trunk-based development might be what you want to go for. And lastly, Gitflow lends itself to like a slower release cadence. And please don't matter me, it does, because it's normally a bit more controlled, and the schedule is usually predetermined. So we're releasing on the 3rd of December, and if you're not done, it's not going in. You need to make sure that what goes in is done. So slower release cadence, you might want to go with Gitflow. But if you're trying to be like Amazon and deploying every second, right, and teams want to iterate very quickly and independently, then trunk-based development might be the thing for you. So look, it's not a one size fits all kind of solution. It has to work for your team, and there are a lot of things to consider. And obviously, like it might be a mix and match. So short answer, no, trunk-based development is not replacing Gitflow.
Cool. Derek, you want to weigh in on that, or Gordon?
I was just going to highlight the comment there by the GitHub account of it depends. So there was a great video from that was released with Universe, which like gets into all of these things. I mean, it's been way too many years now in software, but everything becomes like your whole team will decide like this is definitely the way to work, and then a new guy will join and you'll be like, actually maybe we're doing it wrong. Like you question how you work based on the dynamic of your team. And like it was mentioned already, like if your team's very mature, then trunk-based dev works very well. If your team's not mature, or you don't have quality and security baked into your pipeline, then that's potentially a time where trunk-based is also not ideal for you. But if you want to start moving faster and with more quality, like trunk-based dev is one of the things that you're going to turn to enable that.
Cool. Makes sense. Derek, anything?
I don't have Twitter, so I'm gonna say trunk base for the win. Yeah, I think with yeah, I think it just makes you release faster. Things are easier. Yeah, if you're working with a more mature team and more like intermediate and seniors, it's just easier. Like there's no need to add extra layers and extra processes. Especially like if you're in a startup where you need to release like sometimes every day. You want to get the code out there as soon as possible and keep your clients. So yeah, I prefer trunk base.
Cool. Unless there's anything, I think we have exhausted our time. But gentlemen, thanks again for joining us. Thank you for sharing your knowledge and taking the time. We will make everyone's talks available. Thanks to the community as well for joining in. I know it's a Friday, Friday evening, depending on where you're joining from. But thanks again, everyone. The talk will be available as well. You can follow the GitHub community on Twitter for more updates on community events and all of that. But until then, we will be, please, if you're interested in being a speaker, we will be posting links. Do follow the GitHub account on Meetup to make sure that you're notified of updates, events, and all of that. We do have an event coming up in November. If you're interested to speak, please do just hit us up, connect with us. But until then, thank you, everyone. Until next time.
Thanks for having us, and thanks for everyone who attended. Cheers.
Cheers.
Thanks all.
Bye.
It's great. Thanks.
Bye.